Okay, on this, we're going to apply what we just learned. So remember, AB, by definition, goes the short way around. So I go from A to B, and that'd be that. So that is a minor arc. And it wants to know the degrees. In this case, the only way to find that out is, do you notice it says AC is perpendicular to BE? Remember, perpendicular means makes a right angle. So if that's a 90-degree angle in the middle, that's a 90-degree arc on the outside. So that's how I do that. On the next one, arc ABC, remember 3 letters usually means you're going the long way around. So we're not going straight from A to B, but I'm going from A, have to drop by C. Maybe it's a friend's house, have to drop them off on my way home, and then I make it back to my house. So maybe A's the school, C's the friend's house that's a little out of the way, but they needed a ride, so you're a good friend, and then you go to finally get to your house, going home the long way. And in this case, since we know the arcs add to 3/6, first of all, this is a major arc because it's clearly bigger than half a circle. And to figure out the measure, if you know they add to 360, this arc would be 360 minus 90 degrees, which would be 270. So that gives you an idea of how to figure out some of those arc measures. Maybe one more. If I have A to B to D, notice A, I wouldn't be going the short way around this way. I'd have to start at A, go through B, and then D. You notice, once again, confirm that it's over half a circle, but it is, so this is a major arc. Generally, 3 letters will be a major arc. You could get them to pull a trick on you. You could have them talk about something like arc DCB. If they did something like that, that would still be a minor arc because you notice DCB, let me mark it in light blue here, would go around the short way. So DCB is a minor arc. 3 letters doesn't make it a major arc by definition, but quite frankly, that middle letter is unnecessary because if they just said DB, you would have had the same thing. So they just were being a little tricky or unnecessary adding that C in since it was the minor arc. But generally, you'll notice if you check it, 3 letters will be a major arc. So if I go from A through B and then on to D, I've gone a pretty long way around the circle. I've got a couple options to figure that out. I could say that from A to C is a semicircle, so A to C was 180, and then plus D to C is another 40. So I could do it that way. 180 plus 40 would have been a 220-degree arc. Or the other way I could have done it is I could have said, okay, these 2 angles over here have to add to 180. So 180 minus 40 is 140. And I could say, hey, the green is everything except this piece here. So I could have done 360 minus 140 and also got the 220. I just point that out to show you that there's not a lot of times one way to get the answer to these arcs. Sometimes you could add, I could have added the semicircle plus 40 degrees, or I could have found out that was 140 and subtracted it all. A lot of different ways to do these problems. We're going to go ahead and leave the rest of those on that diagram for you to try on your own. We'll look at a few things down at the bottom here. If you run into any problems, of course, ask me some questions. But this one in the bottom, also remember that RS, first of all, if this is a 42-degree angle here, this arc here, QR, has to be 42 degrees as well. So this is 42, and this in the middle is 42. And that means since from Q to S would be 180, RS would be 180 minus 42, which in this case would be 138 degrees. So RS would be 138. Now, if it says to start at Q, then go to R, then go to S, that's exactly half a circle. That's a diameter there. So that's 180 degrees. If it says to QST, we'll switch colors here. That's going to be QTS, never mind. Let's try again. Start at Q, go to S, then to T. That's 180 to get from Q to S. Plus, if this is 42 over here, this other angle in the middle is 42, this is 42. So you have 180 plus 42 is a 222-degree angle there. So hopefully that teaches you how to do some of these. And the vertical angles that are across from each other are still equal like you've learned in previous math classes.